We will go to exercise 3.3.1 number 1. Okay, look at the claim that or statement that we need to answer here. We need to test here. So we can see that the claim is given here. Okay, same. Okay, can we conclude that the lifetime for both batteries? This is a general statement, lifetime. Actually, the general statement, lifetime here, this is referred to mean lifetime. Okay, sometimes for mean, we can make in a general statement. Okay, lifetime for both batteries. So, the notation used here will be mu, type A, mu A. Okay, type B, that is mu B. Okay, so the relationship between them here, that is equal. Okay, it's the same. Okay, equal. So this is the claim that we need to test. Okay, and for this case, if you look here, okay, for the case of mu, we have two mu here, so we need to be careful with theta. Okay, so theta here, because we need to be careful either that the theta here either under independent sample or dependent sample. Independent means that under the case of mu1 minus mu2 or mu d. So by looking at the information given, okay, we try to look at the information given here. Okay, the standard deviation of lifetime. Okay, this is the value for standard deviation for lifetime. Okay, standard deviation, and this value is free from any sample. So since this is free from any sample, okay, so that's why the notation used here should be sigma A. Sigma because standard deviation. Okay, and the second one, the second data given here, okay, numerical value given here is 0.7. 0.7 here is referred to the standard deviation for battery B. Again, this is also free from any sample. So that's why this will be sigma B. Okay. So now the next numerical value given, if the mean lifetime for 30 batteries, okay, this is the notation for this value, this is equals to n, sample size, but sample size for battery type A. Okay, and here this value is referred to the sample, so that's why, okay, this value, the notation for this value, that is will be x bar A. Okay, and mean lifetime for 35 batteries, okay, this is N2. Okay, sorry, not N2, NB. Okay, and 4.8, this is referred to the mean lifetime for battery type B. So this value will be x bar B. Okay, so now if you look here, we can see that this is the information given. Okay, so now when we look here, the data for type A and type B are independent. Okay, the battery type A and type B has no relationship between them, so that's why this is under independent sample. So the theta used here should be mu1 minus mu2. Okay, so for this case, since this is mu1 minus mu2, and usually, okay, we will transfer, this case we use A and B, so we transfer mu B to the left side. So this will be mu A minus mu B equals to 0. Okay. So this is the claim. That we need to check. So step 1, okay, once we can identify the claim, so construct the hypothesis. Okay, construct the hypothesis, look at the inequality use, the expression used here, this is equal. So since the claim consists of equal sign, so this will be hash null. Okay, and hash 1 here, that is mu A minus mu B not equals to 0. This is step 1. So complete step 1. Okay. So now this is complete step 1. Okay. Step 2. There are 5 formula, is it, for the case of independent sample. So by looking at the formula given, you can see that population standard deviation given. From the population standard deviation, we can get population variance. Okay, we can get the population variance. So for this case, we need to use the formula for population variance B A and B non. That is formula number 1. And then apply the formula, simplify your answer at 4 decimal places. Okay, so now we go to step 3. Step 3, we use in step 3 we want to establish the test criterion. Okay, instead in step 3 we want to determine the rejection region and critical value. The first step, we look at the first factor, we look at the distribution used in step 2, that is Z test. So we need to compare with Z distribution. So you can plot Z distribution here. Okay, Z. So the next one, that is the second factor, that is we look at the inequality used in H1 because we want to identify the rejection region. Okay, so not equals to, meaning that this is two-tail test. Two-tail test means there are 2 rejection region that lies on the left tail and right tail of the Z distribution. Okay, when we have 2 rejection region, automatically we will get 2 critical values. Okay, and our alpha here, alpha given in this question, that is 0.05. So since we have 2 rejection region, we need to divide our alpha by 2. So by using statistical table, get the value for Z 0.025. For the first critical value that lies on the negative area, that is minus 1.96. For the second critical value lies on the positive area, that is 1.96. So complete step 3. Okay, rejection region and critical value for step 3. So now step 4, we want to make a decision on hash null. Okay, so by looking at by comparing the test statistic in step 2, 2.29. Okay, detect, identify the value of Z test either under rejection region or acceptance region by comparing Z test with the Z critical value. So we can see that the value of Z test here is lies on this rejection region. Okay, so now write this in a proper way. Okay, so 2.292 greater than 1.96, and since this Z test lies on the rejection region, so reject hash null. Reject hash null. So complete step 4. Now go to step 5. Step 5, okay, that is depends on step 4. Reject hash null. Reject hash null. Okay, automatically we accept H1. Reject H null for this case means that we reject the claim because claim is under hash null. So for this one, you need to put alpha 0.05. There is sufficient evidence to reject the claim. Means that the lifetime for both batteries are not the same.